most of this section is about learning the derivative formulas of the 6 trig functions so that we expand the types of functions we're now able to calculate derivatives of. But in the process of doing that, we had to learn a couple of new limits. And I've got those on the board. Actually, I've got 2 versions of this second one, so it's 3 limits. Okay. Now, what I've got here is I've let this sort of box here as a placeholder for the input. We learned all of these limits with an x in those positions. So we learned that the limit as x goes to 0 of sine x over x is 1. I've got a box there because we can sort of modify that. It doesn't have to be x. If I've got the same thing in all 3 of those places, so I have a quantity going to 0, I've got sine of that quantity, and I'm dividing by that quantity, I can conclude that that limit is 1. Same thing with the other limit, and I gave you just 2 versions of it. We can either have 1 minus cosine of a quantity or cosine of a quantity minus 1 on top. If we're dividing by that quantity and that quantity goes to 0, we can say that that limit is 0. Now, how does this help us? Well, that's going to allow me to evaluate a few more limits. So let's say I wanted to evaluate the limit as x goes to 0 of sine of 5x over x. Now that's fairly close to this one, except I don't have the same thing in all 3 places. X is going to 0, x is in the denominator, but what I'm plugging into sine is 5x. Now, it's kind of tricky to change the input to a trig function. So I'm going to say my quantity that's filling in this position here is 5x. And I'm going to try to get a 5x in the other places as well. So I would take this and I would multiply by 1 in the form of 5 over 5, because that's going to introduce a 5 on the bottom. So now I've got the limit as x goes to 0 of 5 sine 5x over 5x. Just wrote that extra 5 on top in the front. Notice that's a constant, so I can factor that out of the limit. So I can say 5 times the limit as x goes to 0 of sine 5x over 5x. So I have the same quantity on top being plugged into sine, and then I'm dividing by that. I cannot yet conclude that this limit is 1, though, for a very simple reason. 2 is not the same as 3. We have to have the same thing in 1, 2, 3 places. We're saying here that x is going to 0. Now, if I think about it, if x is going to 0, what's 5x going to do? Something small. 5 times something small is still going to be small. But I need to write that. I'm fine if you just write as x goes to 0, 5x goes to 0. But you've got to write that. I'd also be fine if you rewrote this as the limit as 5x goes to 0 of sine 5x over 5x. This would be fine. This would be fine, including that statement. But I need to be able to see 1, 2, 3 places. 1, 2, 3 places I've got 5x. Once I have that, I can say, oh, that's 5 times 1, which is 5. Now that's a limit that we wouldn't have been able to evaluate using any of the other techniques that we've learned so far. I did mention there's a lovely technique called L'Hopital's rule that we will learn later this semester. At this point in the semester, you're not allowed to use it even if you know it from a previous class. All right, so this limit is 5. Now, I'm going to just show you, and I hate doing this because it's so bad. I'm going to show you how I can make a completely horrible mistake, do absolutely nothing right, and still get the right answer. And the only reason I'm showing this to you is because I want to warn you. Since you get the right answer, if you're doing the work and you're checking your answer in the back of the book, you can, get this false sense of confidence that you're doing things right. But I'm grading your work. And if you get the right answer by doing everything wrong, you will get absolutely no credit. So if you do what I'm about to do, you will get no credit. Here's the totally wrong, horrible, bad way of doing things. Okay, that will give you no credit. So you can't complain that you weren't warned. Limit as x goes to 0 of sine 5x over x is equal to, I'm sort of shuddering as I'm about to commit this horrible mathematical atrocity. Limit as x goes to 0, 5 times sine x over x. I can't do that. Now, if I evaluate this, this is constant. I could factor it out. That is 5 times the limit as x goes to 0 of sine x over x. That is 5 times 1, which is 5. The problem is that these guys are not equal. Sine of 5x is not, absolutely not, 5 times sine of x. I can't factor a number out of a trig function. That is a mathematical atrocity. If you commit that mathematical atrocity, you will get no credit, even though you'll get the right answer. Okay. So sometimes, if people get stuck on something and they look in the back of the book and they say, oh, it's supposed to be 5, and they try to work backwards from the answer, they convince themselves that they can do this. But you can't. Let's just look at an example. Okay. Let's suppose x was pi over 2. Okay. So then sine of x is equal to sine of pi over 2, so it's 1. Okay. 5x would be 5 pi over 2. Okay. Sine of 5x would be sine of 5 pi over 2. Now 5 pi over 2 on the unit circle, that's actually coterminal with pi over 2. That's still 1. That is not 5. Sine can't take on a value bigger than 1. If this were legal, I'd have some places where the value of sine was 5. I know that doesn't work. Okay. So do be careful as you're manipulating things. Basically, whatever you're plugging into your trig function, that's the quantity that you want to get into all three places. It's tricky to change the argument of the trig function, so change the other pieces instead.